This is the chlorophyll that you get in plants. Intensity here, black is the most intense. This is, I hope you all know this is Antarctica, right? Why is there so much black, so much chlorophyll here in Antarctica? This is not the forest. Here is India, here is the jungles of Africa and Asia. There's lots of trees there. Why is there even more green stuff in Antarctica? In the ocean. Because these are what they call photoplankton. They're plankton which exist and process a lot of the sunlight into oxygen and so on. So this is why that's what the whales live on and so on, very rich. So you don't have to just think of chlorophyll as being trees, photoplankton will do it as well. Next. So the way we look for this is we have a satellite, we measure the spectrum reflected back from the Earth's surface, we detect it. Imagine that satellite becomes a spacecraft or a big telescope, we can look at another planet and look for this stuff. Next slide. Next. What sort of molecules might we find and look for to tell us that if we found them in the atmosphere of another planet, would tell us that we've got life? Plants give out lots of emissions. So if we were looking for things, we might look for the chemicals that plants give out. Pine trees give out a compound called pinene, surprisingly. You've seen it, turpentine. You have a cold, you might rub it on your chest, fix inhaler, right? So if you detected a lot of pinene, that might be a clue in the atmosphere there's pinene, therefore there might be plants. Next slide. It might be that there are other things like this, the citrus smell, limonene, you get it from apples, sorry, from oranges and from lemons. If you detected that in the atmosphere, it might say that there are plants giving out that. Next slide. And if you go to Australia or somewhere, you might go to smell the eucalyptus. Eucalyptus, if you found a lot of eucalyptus, that might suggest that you've got plants, eucalyptal type plants. Of course, if you find eucalyptus trees, you always find koala bears. So obviously, if I found a planet in its atmosphere, there was lots of eucalyptal, therefore there was lots of eucalyptus, therefore I would obviously have alien koala bears. Has anybody seen or touched a koala bear? No. Koala bears are very dangerous animals. They're very clever and very aggressive. So if there was an alien civilization of intelligent koala bears, we've got serious trouble. You wouldn't want to mess with them. Okay, next. So, how else can we find about life on Earth? Early life on Earth. We're going to try and look for another planet, but let's come back to our own Earth and see if we can work out how life began here. We want to look for the earliest fossils. The earliest fossils we found are about 3 billion years old. Some people say they're 3.4 billion. They don't find the fossils of life, they find the chemical signature of the plants in the rocks. We also run big computer models to try and work out how life began on Earth. These computer models are what they call probabilistic. They don't give you a single solution. They give you several scenarios of which and therefore this suggests that there might be many ways that life might have evolved. We believe now there is something called the last common ancestor, which then life branched out from, the tree of life, yeah? That might be different on another planet, but we want to find something like that. A computer model will predict the ways that those common ancestor might derive. We don't know that, for example, if the asteroid that killed the dinosaurs hadn't come, if the dinosaurs hadn't been killed by that, would we, which came from the small mammals that survived, would we have evolved or not? Or would we never have evolved because the dinosaurs would already have eaten our ancestors? Or would there have been would dinosaurs have developed intelligence? We don't know. We can run computer models which give us simulations. But we have to test them. Next slide. This is what we think is the earliest life on Earth, or the descendants of the earliest life on Earth. They're called stromatolites. They're basically algae. Big lumps of algae. You find them in a very few places in South Africa and in Western Australia. This is what probably we think is how life on a planet will start. It will start with those bacteria, and it will start with the first kind of life that we kind of recognize as life as plant life, is probably something like this. So the emissions of these things, which change the atmosphere of our planet, they started the oxygen, these are the sort of things we might think to look for. We might think if we see the signatures of them in space, we might know the planet's kind of got to this stage. That's what we're looking for. Next slide. So, coming to the end. This is the field of astrobiology. All the things I've talked about, the physics, the chemistry, the biology, it all has to be brought together to answer those two questions I started. How did life begin on Earth? Is there life elsewhere? Next slide. So, it's a field which combines astronomy, biology, chemistry, physics. You're going to do experiments, engineering, etc. We can try and make a prediction, but I think the prediction is we are planning at the moment a roadmap for science, with space missions and so on, to 2061. It is likely that probably for the younger people in the room, the people who are the students now, if you live to be 80 to 100, as most of you should, by that time in your life, the science would have evolved that we may have solved, and we would hope to have solved, or come a very long way, to answering those two questions I started with. Next picture. But it needs scientists to do it, and we've got to bring people together. This is not a problem that's going to be solved in one country. It's a worldwide science problem. Much the way we do CERN science, or we do other global warming and things, it has to be done across the world. Next slide. The Nobel Prize winners get together every year or so, and as they're very important people, Nobel Prize winners get together to form a club, a very elite club. In 2000, they were asked, what are the big science questions for the 21st century? What do you think we should be doing? The first question which they came up with, possibly because they were relatively old themselves, was aging. Can we slow down aging? The second question they thought we should solve is cancer. The chances are that most of the younger people in the room, by the time you get to your 80s and your 90s, it's the most likely thing you're going to die for. Okay? We've solved most of the other diseases. Heart attacks will probably kill you early. That's the next biggest killer after having an accident. If you've been on Indian roads, it's probably higher. But if you don't die in a car accident and you don't have a heart attack, by the time you get to 80, it will probably be cancer. So we need to cure that. The third question they asked were the questions I started with. That's the big science challenge. Can we answer that question which has fascinated humanity from the early days when the people built the first temples? This is a map. We have what we call, in UK, we have pubs, right? You go and have the discussion in the pub. You know what the equivalent is in India? You probably sit down and have tea, right? And you sit down and you discuss the science problem. And being scientists, you normally have a pen in your pocket. And so you get out, in the pub, you get out the beer mat, right? And you write on it. And you come up with ideas. Having your chai, get a piece of paper out, and you sketch it out. This is the Nobel Prize winner's beer mat. This is how they worked out. To answer this question, you had to do all this science and bring it all together. So for the people in the room who want a career in science, and I daren't ask you to vote on that one because it would be too depressing, because either you'd say no, or you wouldn't reply at all, which is equally bad. I would assume that all of you want to be something in science. If you wanted to work on one of these questions, look at this picture and pick one. And I bet no matter what you do, if you're a biologist, if you're a chemist, if you're a physicist, if you're a mathematician, one of these problems here is for you. The alien's taking it away so you can't answer it. Okay? But that's what we want you to do. Okay? That is almost the last slide, so if it does come back and the alien lets you see it, you'll be able to answer the questions. That's the challenge to you. It's the challenge to the next scientific generation. Next slide. That's what you should do. It could be your career, and as scientists, what we have to do is tackle that. We have to be bold enough to do it. So boldly go forward. That's what the science community needs to do in the next decade. And the last slide, doesn't matter if it comes up or not, is just to recognise my own group that work on this particular part of the problem. But if it does come up, all set. Next slide. Just say keep. I don't care what you do. Just try and get the next one. No. Right. If it comes up in the questions, I'll make a comment on the last slide. So that's the story of astrobiology. That's the story of where we are in trying to understand the problem of life. That's the final slide I wanted to show. I will take questions. I know it's late. I apologise for arriving late, etc. As I say, this is I run several research groups. This is the astrochemistry research group and astrobiology research group. I really wanted to put this slide up for one other reason. If you look at this group, you will notice that it's almost an equal number of men and women. We need more women in science. 50% of the population, slightly more actually, of the Earth population are women. We need to mobilise women, and this is a topic where women can do science. Okay? I will also say that my wife tells me every day that women work harder than men. Yes? Yes, right. Therefore, in the selfish interest of running the research group, I should appoint more women because they will work harder than the lazier men, and therefore I will get more research results. So, notice how many women I have in the room. Then we can make the men work harder too. So, if you want to pursue this idea, if you want to work in the general area, there are careers in it. You may not end up being an astrobiologist, you may go into some other area of science. But I hope that this talk has given you some inspiration for doing science. I hope you will think about some of the things. Think about the known knowns, the known unknowns, and the unknown unknowns. And I will take any questions. I thank you for your patience in staying so late. Thank you very much. And thank you guys for struggling. There is nothing worse when you give a presentation for the AV guys who are probably sitting there. There's a famous talk I went to, which is by a Nobel Prize winner on the ozone hole. He had 1,800 people in an audience to give a Nobel Prize. And at the last minute, the AV guy tried to change the resolution on the screen to make it better. The whole thing crashed, and they couldn't get it back for 2 hours. So the Nobel Prize winner just stood here and talked without slides, and the AV guy went out and shot himself properly, or was shot afterwards, or whatever. So thank you for your patience, guys, because I know that you must be sitting there thinking, oh, I feel so bad. Slides. Okay, questions?
Please ask questions.
Yeah. Don't ask me in Gujarat, because I'm afraid I'll
Just one second.
You can translate. Yeah. They are so shy. Come on. Alien at the back. What's the answer to the origin of life? How did you get here? Come on, any questions from anyone? From this faculty, if not from the students. Maybe start the process and maybe that'll come out.
I have a question.
Yes, sir.
So you mentioned on slide we can synthesize the sugar and the phosphorus and some amino acid on space. So there is some chances to synthesize the DNA at space so we can produce the life.
If we knew how to make DNA, yes, we would be able to start to make synthetic life. You can make synthetic life. You read it in newspapers, people are creating new things. They haven't actually, they haven't started from the building blocks. What they've done is manipulate the DNA that we have. They haven't made DNA from the chemical elements in the same way. You can assemble small chains of DNA. You can chemically put the ingredients together in small quantities, spin them up and make some nuclear bases and so on. You can make the nuclear bases and so on. But we haven't been able to create life in the lab. There are lots of questions about that, about the ethics of doing that. What would happen if that life reacted with our life? It would be a plague. This is one of the questions about bringing back samples from Mars. If we found life on Mars, would we bring it back? Or more importantly, if we go to Mars, we have to be very careful we don't take anything, any life from Earth, that might poison that life. Okay? So there are lots of questions about it. But yeah, why would you do it? What would you want to do? Do you want to really play God? Maybe you would. So yeah, but at the moment we don't know how to do it, so it's a philosophical question. Yes?
I want to know about supernova, sweet spot and Big Bang theory.
Say again?
Want to know about supernova
explosion.
and
Supernova explosion. That's how the dust we get in space is made. Okay? That's how we get one of the best ways of getting those chemical ingredients that we need, the carbon, the oxygen, the nitrogen, comes from the supernova. Okay? So we need, and it produces the dust. So they're the most interesting stars because they're the ones that explode and produce the dust. And then those dust grains eventually form a cloud, and then gradually that cloud collapses under gravity and forms a new star. Everybody in this room is basically a piece of a star. We are all stardust because that's where the ingredients in our bodies came from. Everyone in this room, all life, is a piece of an old star. That's what we are, we're stardust. Okay. There is a known problem. How did we get the first stars? Because we need the dust to make a star. So before there was any stars, how did we get the first one? We don't. The cosmologists can't tell us. Any other questions?
it is true that our universe is increasing size.
Yes. We believe from the Big Bang it's constantly expanding. It might be that the universe has had several incarnations. Some people think it expands and then it collapses and then you get a new universe and it expands again and collapses. Some people believe there might be parallel universes. We might have some people from a parallel universe. There might be another lecture going on in that parallel universe somewhere else at the moment. Okay? Some people believe that. Okay? It might be a universe which is very similar to us, but maybe with slightly different changes. It might be a universe where the English cricket team has annihilated India 4-0. Might be. Don't know. So, yeah, and some people believe that there are powers. That's when you get into cosmology and some of that work there. Again, that's only, we've got no evidence for that. It's only mathematics that suggests that some of that might occur. Astrochemistry or astrophysics, the sort of stuff that Barlow and I do, we kind of start after the universe is possibly about 1 to 2 seconds old. Prior to that, it's particle physics, starting with Higgs bosons and superquarks and everything else. Because we start from the Big Bang. We follow the chemistry occurs after a few seconds. And then we believe the laws of physics and chemistry have been established. We don't know how they're established, but we believe after that, we trust that the physics and chemistry stays the same from the early days of the universe to today. And it's the same everywhere. We have to trust that. There's no evidence otherwise. Any other? Yes?
Why you choose the topic the cradle of life?
Does anybody know?